In this course, we will learn mostly the programming. We are not going to learn how to create microprocessor. That is micro E. Okay? How you create what you call a semiconductor circuit using transistor or using gate. That is the micro E. What we are going to learn here is basically how to use it. Okay? Now, you have learned programming language, isn't it? You have learned C or C++, isn't it? What else you learn? Any other programming language? Java. Okay. Now, programming language are actually can be divided into 3 levels or 4 levels. And the one you are going to learn here is called the second generation. I will explain later on that generation, first generation, second generation, third generation, and the fourth generation. Okay? So what you have learned, Java and C++ are called high-level language. And assembly language is called low-level language. We'll explain later on what's the difference between them. So the focus of this course is actually to teach you 2 things. First is how to program a microprocessor in assembly language. And that's what we will spend the first 9 weeks. The second part, I will teach you how to actually take that microprocessor and make a PC out of it. Okay? I will not cover everything in the hardware. I mean, the what you call how to make really a PC. Because you will be studying another course called computer architecture. But the computer architecture is going to go theoretical, which means it will teach you in theory. They are not going to use any particular microprocessor to build a PC. Here, no, we are going to use specific microprocessor, which is called Intel 8386. Now, why we use that processor? If you look at your tablet or your, not tablet, sorry, the PC or your laptop, you will find most of them written on the Intel inside. So Intel is still the dominant microprocessor in what you call data processing. Yeah, if you want to use like you want to process your data, like spreadsheet, database, word processor. Okay, but it is not dominant in what we call edge computing. Like if you use tablet or handphone, you will not find any single handphone using Intel. Okay, I can spend 1 or 2 hours talking about the family of microprocessor. Although they are all of them, they have similar things, which means basically they're made of hardware and software. Okay, their philosophy is slightly different. Okay, so Intel started with data processing and it's still the dominant in data processing. If you use edge computing, you will find like ARM, okay, which is totally different philosophy, different architecture. And because they are different architecture, they are not compatible. Okay? When you study, I think you study embedded system next semester with Dr. Madina, or this semester. Embedded system. Either this semester or next semester, I don't know. Embedded system, Dr. Mazlina will teach you using a microcontroller. Okay, either they use a PIC or I don't know which one microcontroller now they are using, or you use Arduino or whatever. These are not compatible with data processing. Why? Because microprocessors are mainly they are different into two things. First is based on their architecture. We have what's called CISC and RISC. Okay, which is complex instruction fed computing and reduced instruction fed computing. These are the two main divisions of microprocessor. But then again, we have microcontroller. So what's the difference between microcontroller and microprocessor? Intel, they do have also microcontroller. The difference between microcontroller and microprocessor is what they are designed for. Microprocessor is designed for data processing. Microcontroller designed for event, to control event. So, for example, if you go to expensive car, you will find a microcontroller inside actually, which actually monitors the whole your car. That is microcontroller. So microcontroller, they have a lot of I/O pin for connecting to sensor. They have timer. This one, no. This one have a huge memory for your data. Another data bus. So their architecture is different. So we can look at microprocessor and microcontroller from the architecture and from the application. Okay? So our focus here is on microprocessor for data processing. Now, whatever you learn here will be useful for you in the other two subjects, in embedded system as well as in computer architecture. Okay? So that's the introduction of the course. Now, we have exactly 3 course outcomes. You can see them. Okay? So the first one is build assembly language program and design interfacing circuit and analyze and modify interfacing circuit. So the first one is actually for the programming part, which is the first 9 weeks. The other 2 are for the last 5 weeks. So the focus is actually on the software part, on the programming part. So how the assessment? First, you have 15 mark is short test, and this is individual. What do you mean by short test? The first 2 weeks, there will be no test. After that, you will have short test. The short test will be given at the beginning of each lecture, exactly 15 to 20 minutes. Okay? You come late, sorry. You do not attend, there will be no replacement. But if you have an excuse, like the university asks you to participate in university activity, or you have an MC, you won't get the 0. So let's say I have 5 what we call short test. You only attended 4, you will get the average for the 4 tests. You will not be penalized if you are legally allowed to keep the class because of either medical or university allow you to do activity. But if you do not have any of these two and you don't attend the test, you will get a 0. Okay? The next one is 15% innovation report. This is done in a group. What I mean by innovation. Now, in this class, I'm not going to give lecture, only the first, probably today and next. This week I will give lecture because I haven't done anything yet. After that, I'm not going to give lecture. The lecture will be uploaded there. You read them. What I will be doing here is actually writing code. You don't learn code by what you call reading it. It's not like logic. You have to learn Boolean algebra. Programming, you won't be able to do it by memorizing syntax. Okay? You learn it by doing. And that's what we will do. We will write code together. I will write the code with you from scratch, which means there will be no program ready. I won't bring the code and show it to you. I won't bring the flow chart and show it to you. We do it together. Now, so what's the innovation? Now, once I give the code, most of the time the code is not really complete. It still can be improved. Okay? So that's the innovation. So we will start with the code, we make sure it works, and then I will ask you to improve it. And you do this one as a group. So this is, you can think of it like an assignment. But I have assignment later on. Because for the hardware, I will give you assignment. For this one, we call it innovation. Huh? And then we have 10% on lab test and 10% on test. This is individual. So what's the difference between lab test and test? Lab test is for the coding. So basically, you have to write the code, write a program. It is not, I give you a question and you give the answer. While for the hardware, no, that will be like what you study in logic. I give you a question and you have to answer it. So that's what we call them the test. So lab test is for the programming, test for the hardware. And then 20% on assignment. This assignment for the hardware. Okay? And 40% on the project. And this is a group project. Any question?
Doctor,
Yes.
how many person in the group?
How many person in the group?
Yes.
Exactly like what we did in logic.
So
Okay?
Okay.
4 per group. Okay? 4 per group. And you can start today, form your group. Who is the class monitor?
It's me, doctor.
Okay, so make sure by next week I have the group. You send me an Excel file or Microsoft Word file. Group 1, who are only need the matrix number and their name for each group. Okay?
Okay,
Is that
doctor.
clear?
Okay, doctor. Okay,
Okay.
doctor.
So now we go down to the activity. Okay, what you will actually doing. So you can see here the first one, reading. Reading is what you are supposed to read. I haven't put for you introduction to assembly language programming. Okay, I will put it for you. Okay, I actually have wrote the book about this, the programming part, and Penelope QMS is publishing it. But they haven't given me the book is already in the, I mean, already under printing. So you can buy it from them. Okay, so, but I will put some lecture note for you. Now, activity here is what actually we will do in the class. As I mentioned, I won't give you lecture. So you can see today is setup tool. So after I finish this one, that's what we will do. We will set up the tool you need for this course. And assessment is if there is any assessment. Okay, so you can see the first week, no assessment, huh? Then you can see the short test 1, short test 2, short test 3, short test 4, okay? So you can see there's a short test almost every single lecture the first few weeks. Now, as I mentioned, this will be given at the beginning of the class. The short test will be put in on ITEL, the question itself. The answer, no. The answer, you must do it handwritten and handed here before the class. Okay? Now, the first 2 weeks, this week and next week, we will be doing what we call hybrid. So the short test will shift 1 week. Okay? However, the number will not change. The only difference, they will shift 1 week because I do not want to give short test and you do it at home. Short test must be done here. Okay? So you can see up to procedure, we have the software. Now you can see there's short test and there is a report, isn't it? The report is when I give you innovation. Okay? So initially there is no innovation because we haven't learned enough skill in programming. So you can see only short test 1, 2, 3. Only after short test 4, when we learn about program control, where you can actually write some simple program, then we start doing the innovation. Huh? So innovation does not start the first 5 weeks. Any question? Yes. Yes. The language is called assembly language. Yes. You haven't done assembly language, right? That's what you are going to learn here. I will explain what is assembly language. Okay. So I will explain about assembly language. But what's important now, you have any question about the syllabus? Anyone have a question about the syllabus? Assignment 1, assignment 2, both hardware. Mm. That I mentioned. If you look here up to procedure, we are dealing with software. Huh? Only when we start bus operation, memory interfacing, you can see in the class here, there are no more. We start doing tutorial, isn't it? When we are doing tutorial, is hardware. This is like what you study in logic. Actually, some of the logic information, you need them here. And that's why you can see you have assignment, assignment 1, 2, and test. And there's your lab test. So the lab test is toward the end of your software, learning the software. Huh? So the focus is on the software, not much on the interfacing. Because the software, you won't learn it anywhere else. The interfacing, part of it you will learn in computer architecture. But as I mentioned there, you will learn the concept. You won't have what we call hand-on. Here we are going to build actual circuit for a specific microprocessor, which means if you actually fabricate that circuit, you make a PCB, you can build your own your own PC. Except we don't have we are not going to deal with hard disk and what you call your keyboard and so on. But what we will learn interfacing with I/O device. Okay. Any more questions? No. Your final exam is replaced with your project. Okay. Remember the project, however. I haven't given you the marking for the project here. The project have 3 parts. Although you have 40 marks, not every member of the group will get the same mark. Now, 30% of the mark will be given to the code. Okay? And 30% of the mark, the other 30 will be given on the test. How you actually test your program to make sure it works. And will be 60 marks will be given to the group. So the whole group will get 60 out of 40 the same mark. Now left 40 marks. 40 mark Q&A. And you can see the Q&A. So each person in the group, I will ask him question. Okay, on what he have done in the code. Why you put this command there? What this command will do. Okay? Explain this flow chart. What happen if I change this one to this? So this will be individual. So each student will be asked few questions. If you answer all the questions correctly, you will get the 40. If every question you get it wrong, 10 marks will disappear. Okay? Understood? Because I don't want students to be in a group, but they learn absolutely nothing. Okay, any question?
No, doctor.
Okay. So there's no question. Let's look at the tool you need. Today, as I mentioned, we set up the tool. Okay, let's look at the tool. I put for you here, one of them is I put for you a URL and GUI Turbo Debugger, isn't it? So go ahead and download this software. Remember, in C, you have a C compiler, isn't it? Or C plus compiler, isn't it? So here, we will use this GUI Turbo Debugger. If you cannot, if you have problem, you let me know, huh? Download and install. Okay, everyone, managed to get it? Huh?
Yes, have it.
Okay, so now, what do you need this one for? Let's see here, I have the, already install it?
Yes.
Okay, so we will use this one to run exactly like what you have done with your, what we call it, C++. Okay? So the next one is the user manual, 8386 user manual. Can you get it? Oh, okay.
It's on ITEL, yes.
from ITEL, downloaded is from MIT. You managed to get it? Basics Programmer Reference Manual. If you look at the year, is 1986. Probably some of you were not born that time. So it is an old microprocessor. Okay? So why we are still using that microprocessor? For two reasons. The first reason is that there have not yet been major what we call changes since then. You may say, oh, there are plenty of changes. Yes, in terms of the manufacturing part, which is the technologies they use to do the fabrication, the number of transistors they put, how many cores. But we are not dealing with that. What we are dealing with is basically how you use it to make a PC. Now, if you go and buy your laptop or PC, you will find that it's either 32-bit or 64-bit, isn't it? This is 32-bit. Okay, so this 8386 is 32-bit. So it's still relevant today. But why we use it, we don't use a new one? Well, for the next reason is that this one is simpler in terms of interfacing. So if you cannot start with very complex one, but this one's still 32-bit. Most universities, they're still teaching the 16-bit. So this is the 32-bit. But if you look there, it is 400 plus pages. So you don't need all of it. I mean, you can read all of it if you want to. But what we are interested here is chapter. There are certain chapters which you can read them if you want. Okay, like chapter 2 will talk about the flat model and the segmented model and talk about the register. Okay, I will spend one lecture talking about this. Okay, so chapter 2 is relevant, but you can see it is around 40 page, around 20 pages, so you can read it. It supports what I'm going to teach you. Okay, chapter 2. And then chapter 3 is actually cover some of the topic which I'm going to explain, like data movement instruction. I will have one chapter, one whole lecture talking about data movement. Why? Well, you will see later on that data movement, if I write a code, 80% or 70% of the code will be data movement, moving data between the register and the memory. That's what actually most of the time the microprocessor doing, moving data. So you can learn about this one, although I will explain it. Then you have arithmetic operation. Okay, which again I will explain. And decimal again, we'll talk, I will explain again, Boolean operation. So all this one, I will show you. We are not interested in chapter 4. System architecture is not really relevant to us. Memory management, not that much. And chapter 6, protection, no. Multitasking, no. I/O, yes. Chapter 8, I/O. And that's what we will do during the hardware. Huh? Exception and interrupt, you don't need to deal with it at the moment. Initially, I used to have one last lecture about it, but it's not enough time to cover everything. So I removed the interrupt. But if you want to build an actual PC, you cannot do it without an interrupt. Okay. We are not going to deal with co-processing. Debugging, we do not actually, we use a software for that. But you look at chapter 17, which is the instruction set. Now, this chapter, you use it as a reference. Remember, when you study C++, you need to know what are the command, C++ command, isn't it? Right? In microprocessor, we call them instruction set. And this one have all the instruction set, chapter 17. In my lecture note, in my program, probably I will use around 10% of the instruction set, 10 to 15%. So the rest you have, whenever you write the code, you refer to them here, chapter 17. So chapter 17 is very important for you as a reference. Then chapter 2 as an introduction. This is the model and the general register, and that's what I will start with. Then chapter 3, and that's it. Chapter 2 and 3 and 17. Okay, any question? Any question? No one saying yes or no? No, okay. Now, the last section we have is DOS interrupt and function code. You download this guy again. This another book. You managed to get it? Everyone managed to get it? Okay. The most important for you here is chapter 6. DOS interrupt and function call. Okay? Now, this use it as a reference. Now, why you need both? So, when you study C++, you only download the C++ compiler. That's it. Right? Why here you need three tools? You need the GUI debugger. You need the Intel programmer reference, and you need the DOS reference. Without these three, you cannot write a single programming, a single assembly language program. Why? Okay. Now, the microprocessor which we are going to use is called Intel 8386. There's two versions of them, SX and DX. Doesn't matter. It comes from Intel. So in order for you to use it, you must have the Intel programmer reference. So you can get the instruction, which is basically the command you use in C++. Okay? Is that clear? So you need that. But this have the instruction set, they do not provide for you any means of actually running this instruction set on the microprocessor. So in order for you to communicate with the microprocessor, you put the microprocessor in a PC like this, you have no access to the microprocessor. You need the operating system. Like now we are using Windows, isn't it? So you can access the microprocessing using Windows. However, programming using Windows, it is not easy. Although using Windows is very easy, programming, when you study C++, you use DOS, isn't it? Which means you get the black box and you cannot use the mouse. Can you use the mouse with DOS, with C++? When you learn C++, you run your program. Can your program, for example, have an icon and you click on it? No. So it doesn't run under Windows, it's running under DOS. Okay? The same here, we are going to use DOS. Now, if you want to use DOS, you need a way of communicating with it. Now, in C++, the compiler do that for you. In assembly language, sorry, you have to do it by yourself. That's why you need the DOS reference. Because in assembly language, we have absolute control over the hardware. I can write code which makes the computer hang. You cannot do that in C++. You have absolute control over your hardware. Because of that, you have absolute control, but it is not easy. So the higher you go up in what we call the level of abstraction, yes, become easy, become separate from the hardware. C++ can run on any PC. The code I'm going to give you, it will only run on Intel microprocessor. So you must run it on a laptop or PC which have Intel microprocessor. It will never run on an Apple or on this tablet. Okay, even C++ code will not run unless you recompile it. This one you cannot recompile it. It's specifically written for that. So it's called hardware dependent. So we need DOS. That why we need the GUI. Well, where you type your code. So the GUI provides you for facility which is like text editor. So you can type your code, then you can execute the code exactly like your C compiler. It do the compilation. But the instruction set are not part of C. The instruction set or the GUI. The instruction set are from Intel. So you need to know what are they. Okay? And GUI is actually it's just the interface. The code behind it is called turbo assembler. Okay? So you need to understand also the command for turbo assembler. So we need to understand turbo assembler. We need to understand the menu for the GUI, which is quite simple. You need to understand how the microprocessor look like, which we call it the programmer view. And we need to learn what are the instruction set, and we need to know what are the DOS functions. All this one you need to know them before you can actually write your first program. Any question? Or output? No, those used for for any input output. See, the microprocessor have no instruction. In C, for example, if you want to print something, you have command called print, right? If you want to input, you have command called input or read. If you look at the instruction set for the microprocessor, it have only command to deal with the microprocessor itself. Okay? It can read the register and it can read the memory. It has no instruction for input output. Why? Because every input output device is different. So if you want to deal with I/O devices, there where you go to your DOS, the operating system. That's operating system have means of communicating with the input output devices. So you only need the DOS when you want to read or write. So if you have your program have no input, no output, you will never need DOS. Okay? Any question? No question. Okay. Let's see if I can join from these two systems. And then I will share, because on this tablet, I cannot share what we call it. What I have, the GUI, because GUI debugger will not run on the tablet. It will run on laptop, but doesn't run on tablet. because this tablet is not Intel. Let me try to. Uh, and this one have no microphone. Okay, so far I ask you. I want to replace the class on Thursday with Wednesday. So far, only 11 people have responded because this Thursday, unfortunately, I have to send my daughter to the airport. Okay, it seems the majority. So we will do it on Wednesday the same time, huh? 8 to 10. And Thursday is 8 to 10, isn't it? Unless you want different time, I have no problem. As long as it is on Wednesday. You want at 9 till 11, I have no problem. And we will do it the same as hybrid, huh? That day I tried and give.
Doctor, can
Yes.
we do it at another time?
What time
At
you want?
Wednesday?
What
Not
time?
2
What
4
time?
or
Huh?
2 4 2 4
2 to 4 is
Wednesday?
already late. Those who are fasting will be already. I prefer it. I prefer before lunch. I'll, okay.
10 12,
Who?
12.
Okay. Who's the class representative? The class representative. Please create another poll. See what time people prefer, huh?
Okay, doctor.
Okay. I have no problem. Can you hear me? I can both one. Okay. Okay. What's the problem? Then why you're not in the call? You request to go inside? I don't get your request. Now you join. Okay. So let's look at one of the, this is one of the code. I have done it previously. So let me explain to you. So basically what an assembly language program will look like this. But I can start with a new one. When you start with a new one, you click here, open. Okay. Start like this. So as I mentioned, the first program you learned in C was something to display the word hello world on the screen, isn't it? So I will do the same thing here in assembly language, but it will make display the word welcome to assembly language programming. Okay? So in C, you learn to give comment, isn't it? Here to give comment, you put semicolon. Okay? So I will call it welcome. And the extension .asm. So the file, we call it welcome.asm. Although the file have not been saved, you can see it's written here untitled. Right? So if you want, I can click save here. And it should ask me what name I want. Okay? I will call it welcome. Of course, you need to specify where you want it to be stored, isn't it? So this is window. You decide where you want to store it. It's a good idea to create a folder where all your code will be stored. You decide where you want it and save it. You can see now it changed. Okay? Now, comments basically are used only for you. The compiler will just ignore them. So it doesn't matter what you write there, as long as you have a semicolon, and you can see it's like green. So it's telling you this is a comment. Now, you can write as many comments as you want. So I can write, for example, the description, a program to display welcome to assembly language. Okay? So now, the first command we have to put here, everyone, please follow, type the code. So I'm doing it. The first thing you need to put, you have to tell him what model you are using. What do you mean by model? In assembly language, we have two models. And if you remember, let me go back to you. Let me go back to your course, and if I go to user manual, and in chapter 2, you can see 2.11, the flat model, and 2.12, the segmented model. Okay? Can you see them? Okay. And this is basically have to do with memory management. Okay? Now, Intel use the segmented model for most of its microprocessors. It does not support the flat model. But the assembler does, because the assembler is not written for Intel. It's written for any, you can use it for any programming, for any microprocessor, as long as the code you write there is for that assembler. Okay? So we have to use segmented. I will explain what is segment later on. In the segmented, we have 6 different models, depending on how many segments you want to use. So for the time being, I will write one model and you just follow it. So you must type the command .model. This is not, the .model is not an instruction to the microprocessor. These are instructions to the compiler, so which is the assembler here. So we call them directives. So .model and the model type I'm going to put small. And this basically is called directive to the assembler. Okay? You must put the model as the first directive. You cannot put any directive before it. You can put comment, yes, but nothing else. Okay? You must put what's the model, because basically when the assembler try to compile your program, before it does, it needs to know what model you are compiling for. Okay? Now, the small model can support 3 segments. One we call data segment, one we call stack segment, and one we call code segment. These 3 you must know. The stack segment, I will use it here so you won't get the warning, no stack, but is actually not used in this program. Okay? We will talk about stack toward the end of the programming chapter. The programming section. So again, if you want to declare the segment, we put dot, okay, stack, and you specify how big is it. Okay, so this is basically uh, declaring a stack segment. A stack segment, basically, we don't do anything with it at the moment. Actually, declaring stack is always like that. We only declare the size of it. The maximum size is 64K. So here is 200H is half a K. Okay. Now, the second one I'm going to declare is my data. Now, in C or C++, you declare your data by giving them their type. Is it integer? Is it float? Isn't it? Here, no. The microprocessor actually does not understand the difference between data type. So when we declare a variable, we just tell him how much space it needs on your hard disk or inside the memory. So we declare its size. But we declare its size in terms of what? In terms of byte, word, because memory is either byte or word or double word, which is basically is made of byte. When you have your hard disk or your memory, when you buy your computer, they tell you, okay, I have 64 gigabit or gigabyte, isn't it? So that's a space, storage. So here I can tell it my variable will take 2 bytes, or 1 word, or 4 bytes, or double word. Okay? Now if I declare byte, then there's command to deal with byte. If I declare a word, then when I move it, I must move it to a register which can actually store word. So the size is very important. So I'm declaring my message. Remember, I want to display welcome to assembly language, isn't it? Okay, so I declare first my data segment. I call it data. You do not specify space for it. How much? The data size will be exactly how much you store in it, but maximum 64K. So data, I can declare my variable. To declare a byte, we use db, define byte. So my message, I'm going to call it message, which is the variable name. Then declare byte. db is directive. Can you see the color? It's the same like model.stat, isn't it? So this is a directive, which means it's telling the assembler. When I assemble later on, you will never see the dot model, the dot stack, the dot data. You won't see them. Okay. So db, then I can put it into quotation. You can use single quote or double quote. You will see it. Okay. And then welcome to assembly language. Okay. So notice when I put the other one, it become red. Red is that your data. Huh? I can put the comment if you want that. Okay. So this is basically declaring my variable, which is a string at the moment. But the microprocessor does not know or doesn't actually care what type it is. Okay? Now I need to. So far, I haven't tried a single instruction, huh? there's no code. To start the code, you put dot code. This is your code segment. So inside the code is where you write your 8386 instruction. Okay? Now, you need a beginning. You need a start for your code. Well, basically, the start is a reference where the microprocessor will refer to it to start your code. The microprocessor only deal with binary, yeah? It does not actually know anything else. So we can write any label, but I prefer to write label which have meaning to you. So I will start. I use the word start, and label must have a colon at the end. Okay, they must have a colon, two dots on top of each other. So your code must start with a label. Okay. Now, the first thing you need to do, I need to set up the data segment. If not, the microprocessor have no idea that where your data is stored because you use register. So we use the move instruction. And as I remember, move instruction, data movement. Okay. And this is a register. And this is a directive. Sorry. So, and then we put it in another register. This is both command to set up the data register. If you don't set up your data register, the microprocessor will not find your data. So these two commands, normally they are part of every single code. You can see them here. Let's go back. If I go back to my old one, you can see here. Can you see them? Huh? Okay. So this will be used in every single program to set up your data segment. You need to set up the data segment only scally, one time only. You don't repeat it for every single variable, huh? We are not referring to the variable, we are referring to the data segment, to this guy. Any question?
Is it simply
Is a simple language?
it's a case sensitive.
No. Case sensitive or not, it depends on the compiler. Okay? It has nothing to do with the instruction set per se. It is depending on your compiler. This compiler, turbo assembler, is not case sensitive. Okay. So now I set up the segment. Now, I'm going to display it on the screen. Remember, I/O, you need to use DOS. Okay? And so therefore, you need to know which DOS function. Let me go back to your DOS function. This is not the DOS function, huh? I have to go back to the DOS function. and show to you how I get. So we go to the DOS function call. You go back to your DOS function call, and you go to chapter 6. And you can see the DOS function are listed in alphabetical order. Okay? Can you see DOS function number 9? 09H. Print screen, isn't it? Can you see it? DOS function, the DOS function, go to chapter 6 and look at the DOS function listed in code in number. So you can see 00, 01, 02, 03, 05, and in front of it, they tell you what is it. So if you look at number 9, it says print screen, isn't it? Can you see it? Huh? The DOS function, chapter 6, at the table of content. Okay, look what the page number. It says 658, isn't it? So chapter 6, page 15, isn't it? So we go down until we reach chapter 6, page 58. You scroll until you reach chapter 6, page 58. I will show you how to use it rather than. So you have to scroll really down. $6.18 now. Let's go to 6.50. Huh? No. It's called print screen. Print string. 09. Because you are not reading from the keyboard. We are just displaying something on the screen. 6.58, huh? Can you see 6.58? Let me share with you. I will change my sharing. Okay, can you see it? 09. Okay, so let's go through it. What it says? Purpose. What's the purpose of this command? It says output the character in the print string to the standard output device. Whatever your output device is it printer, is screen, okay? Now on entry, can you see on entry? On entry means before you issue this command, you must put in AH 09H, okay? And then DX must point to the character. We already have set up DX. DS already set up. I only need to set up the DX. Okay? On return, nothing. Okay? So, how we do it? Now, let's do it So first I need to set up AH. So move AH9. This is the DOS function. Okay? Then I must set up DX. I already set up DS up there. So DX. The DX must be the offset because this one is the segment of the message. So this must be the offset. The address for a variable always have two parts, the segment and the offset. The segment, you only need to do it once. The offset, no, for every variable. It's like looking at your accommodation. So the segment, let's say, is what do you call it? The accommodation we have here, like the name of the accommodation. The offset is the address to your room. So all of you may have the same college, okay? But each one have different room. So we only need to set up the college one time, but the room for every single variable. Okay? Sorry? No. What? Change what? The name of what? No. If you look at what I have showed you earlier, let's go back to the let's go back to your DOS manual. Note, look what it says there. This register, you cannot change them. These are not variable, huh? These are specific register within the microprocessor. That's what we are going to study next lecture. Just today, I just to show you how you actually, how the assembly language look like, okay? This one, every DOS function, you must read input, output. You cannot change, the variable name is up to you. The register name, no. Okay, is that clear? That's what makes assembly language more difficult than other programming languages. And after that, you must tell DOS to execute this one. And to do it, interrupt 21H. Again, this one you cannot change it. Interrupt 21H is the only interrupt which call DOS to execute DOS function code. And don't forget the H. H is in hexadecimal. If you remove the H, 21 is different than 21H. 21H is number 33. If you put 21, it's 21. Like going to the wrong address. Okay? Is that clear? Now, this will actually print the welcome to assembly language. But we need to terminate your program. This one you will never see it in high-level language. In high-level language, the last instruction is done, that's it. Because in high-level language, you never actually leave the operating system. It automatically go back. This one, it doesn't. Okay? So you must terminate your program and go back to DOS. Okay, so how we do it? There are two ways we can do it. One way we can use DOS. So let me show you how we use DOS. We go back to our DOS. You can go back to the label, to the content if you don't know, but for me, I know where is it. So let's go down. Why like not moving? Oh, sorry, I'm wrong. We go down till you reach 4C in hexa. So it's a quite long way down. This one is 2E. Please see, I have 4C I need, huh? Okay. 40, then 41, 43, 44. Okay, and then still 44. Some of them quite long. Then A, then B, then 4C. See what it says, 4C. Terminate a process, exit. And this one, purpose to terminate the current process and invoke transfer control to the invoking process, which means it will terminate your program and go back to DOS, where we start. Okay? So AH must contain 4C. AL, you can put anything. Return nothing. Actually, in return, it will just return what you put in AL, a code, but you'll never see the code. Okay? So what I need to do is I use this command. So I need to move AH or CH. Again, this is DOS function. And I need to again execute it. To execute it, always interrupt 21 hash. And to terminate your program, you have to tell the assembler, this is the end of my code. This one is directive. This is terminate your code. And this is a directive, huh? You have to terminate your code. And you use the same label here as you use here. Must be the same. Okay? But you don't need the colon. Any question?
Why type AH31 instead of 21?
Huh?
Why type AH31?
What AH21? Huh?
Interrupt.
Interrupt 21H. Ah,
Why like AH31?
AH? What AH21?
It's like the mobile.
No. Don't mix up. 21 is a number. AX, BX, TX are the name of register inside the microprocessor, which cannot be changed. Okay, interrupt require a number. The number go from 0 to 255. Which one to use? You have to read both DOS and Intel to understand which interrupt are available for you. You have no absolute control. The one have absolute control are the one who created the microprocessor first, Intel, tell you which are the interrupt reserved for me, and which one the user can use. Now, DOS create the operating system. Tell you, oh, from this, which are reserved for the user, I have used this. You cannot use them. And this is what left for you. So interrupt 21H, it's reserved by DOS for DOS function code. You cannot change it. No. That is a number. The same for AX, BX, DX are the name of a register. Next lecture, I will explain to you what are the register, what is a register used for. Okay? At the moment, what I want you to know is how we create a program, the directive, because this directive have nothing to do with the Intel, have nothing to do with DOS. This only involve the turbo assembler, which is what you are using here. So you need to know the directive. Okay? And I will show you how you run the program. And then how you compile it. And then I make intentionally a mistake, which you will see later on. And I will show you how you fix it and why this mistake is. Okay? Yes. Sorry? Yes. A comment always preceded by semicolon. Okay? Most of the directive have dot in front of them, but not all. Okay. So now I have finished my program. You can do two things. First, you can you see run the executable? Huh? The one which is like a triangle. Or you can actually assemble and then build and you have run. They are not the same. So assemble is like what you do compile in C++. Okay? And then build similar to what you have. Basically, building is if you have more than you have a library, you want to add it to your program. But or you can run. Run will do all the three. Okay? Once you run it, you look down there, written output, isn't it? This is the output of the assembly process. It's the output for the compiler, not the output for your program. Huh? When your program runs, it will open a new DOS window. So let's run it. It tell you that the file has not saved, so save it. Okay, let's tell you this is not assembled. Assembled, yes. So if you do look at down there, it said assembled, isn't it? The code assemble process completely successful, yeah? Then ask you, do you want to build it? Yes. And you can see it open another window. And if I share my screen, let's share the whole screen. It's okay, so weird. I understand. I intentionally do weird program for you. Okay. I will share the entire screen with you, huh? You may have an infinite share, but you can see what I got, isn't it? You get some rubbish like this, right? Right, when you get rubbish, right? Okay. Let me stop sharing first. Okay. Let me show you why you get the rubbish. Let's go back to DOS manual. Can you see the DOS manual back? Now I have to go back to my DOS function number 9, huh? I know what caused the problem. You may not know because you haven't read it. And I did not tell you because I want you to see what happened. This was an intentional error, huh? Go back to your DOS function number 9, huh? Okay. Are you back to DOS function number 9? Okay. Let's look at that remark. Read the remark. What it says? By a dollar sign, isn't it? So what does it mean? Let me show you what does it mean. For that, I need to share, stop the sharing there. This is my message, isn't it? So I must terminate it with dollar sign. So I must put dollar sign here. Okay? You put dollar sign there. Now run it again. So now you can see welcome to assembly language, isn't it? Okay, seems everyone want the class 10 to 12 on Wednesday. Okay, no problem with me. You want to come physically here? Okay. I will do it hybrid. So if you want to come, I can. Okay. So it says press any key to exit. So press any key, it will close that one. So any questions so far? How about the one outside? Okay. So let me get the kahadiran. Remember, if you have any question, you can always use the WhatsApp group or the ITEL. Do not send the question or whatever to my WhatsApp because I don't want everyone asking the same question and I have to repeat the same answer multiple times. So you ask in the group. Seems our OB system is cannot want to create the slot. Yeah. Huh? Oh. Okay, let's try to see if you can log Hadiran. I think the number of students is only written there 5. I don't know why it's supposed to be 20. Try to. Oh, you are not seeing it yet, right? Oh, sorry. If you haven't registered in SMP, your name will not. You cannot do the Hadiran. Even manual, if you haven't registered. Huh?
The camera on my phone has a problem.
You don't need camera. It's scan. Oh, you know, okay, matrix, you can add from here. Type your matrix. What's your matrix? If you want to scan it. Huh? This one? If you have registered, then okay. If you register, you can. Okay. If you have already scanned your Kahadiran, you can go. See you tomorrow at the same time, the same temperature, 10 to 12, huh? I will try to put for you some of the lecture notes.